Hey guys, this is Coach Lowe, and we're talking a little three-dimensional figures today. Chapter 1, Lesson 7, last one of the chapter, and then we'll wrap up with a test. So three-dimensional figures, add these to your definition section. Polyhedron, it's a solid, and it has all flat surfaces that enclose a single region of space. The flat surfaces are called faces. Those will be polygons like a pentagon or a square or a triangle or a rectangle. The vertex, that's that point that we've talked about. It's a point where three or more edges meet now. Polyhedron are classified as prisms or pyramids. You can see these first four down here at the bottom. They are prisms and pyramids. So the first four would be polyhedron. And the last three, they're three-dimensional, but they are not polyhedron. They don't have flat surfaces. You can see on the cylinder, the sides are round. The cone is the same way, and the sphere, of course, looks like a ball, so it's very round. Polyhedra are named, and that's plural for polyhedron. Polyhedra are named by the shape of their bases. So this first one, pentagonal prism, that's because its base is a pentagon, 5 sides. The bases do not have to be sitting on the table or at the bottom of the figure. They can be on the sides, and that's fine. The way you can tell if it's a base is you'll have two congruent shapes that are opposite each other. They're connected by lines by the other faces, by parallelogram faces. And then when we look at the pyramid, it's also named by its base, but instead of extending those sides or the edges out to a shape that looks exactly like it, like the prism, it goes to a point. All right, so you can check those out as well. So we have a square pyramid, a pentagonal pyramid with a pentagon as its base, and then a rectangular pyramid. All right, so let's talk about whether the solid is a polyhedron, and then we'll identify see if I can get this to move down. Identify the solid. If it is a polyhedron, then we'll name the faces, the edges, and the vertices. So if you want to pause the video and try that out, please do so. Actually, you should do that. It's not if you want to. Do it. All right, I'll give you a few minutes. All right, now that we're back, we are going to check these out. Number one is a no. It is not a polyhedron. It is a cone. It has a circular base and it has rounded sides coming to a point. It is a cone. It is three-dimensional, just not a polyhedron. Same. Number two is not. It is a sphere. It is a sphere. Number three is a yes. It is a polyhedron. We can name it. It's hexagonal. It's a hexagonal prism. Hexagonal prism, I name it by its parallel faces. And so the first face that I see, the polygon, is 5 sides, and it's ZPWXY. ZPWXY. When we name these polygons, remember, we're going to go in order, and it doesn't matter where you start or which direction you go, but once you start, don't pick your pencil up. So ZPWXY. Gets me all the way back around. Now I'm going to go ahead and do its parallel side at the back, and I'm going to start at the bottom at R. RSUVQ. RSUVQ is the hexagon on the back. All right, now I am going to do the rectangles on the sides. All right, so let me take those off, and let's do the rectangles. So I have these rectangles on the sides. I should have 5 of those. So YUVX, rectangle YUVX. Let's get this one on the front, XWQV. Let's get the one at the bottom, PWQR. Let's get the one on the side, ZPRS. And let's get the one at the top, ZSUY. All right, so those are my 5 rectangles. I'll go ahead and put commas in there. You can put little rectangle symbols in front of them, totally fine. It also says that we are supposed to name the edges. The edges will be line segments. So let's do that really quickly. So I have PW, put segments over those, WX, XY, YZ. Kind of get the point here. So you're going to go through and name all of those. WQ, so start at a vertex and go. PR, ZS, YU, and XV for this last one. Then you're going to name all 5 on the back side of that pentagon. So SR, RQ, QV, VU, US. That would take care of all of those. Vertices, you're going to take all the letters. Those are the vertices. All right, so Z, Y, X, W, P, and then take all the ones off the back. S, R, V, Q, U. Got them. All right, number 4, doing the same thing. All right, what's the name of number 4? Triangular prism. Triangular prism. The base is a triangle and it is a prism. All right, so there's my base. I know that it is because there's the congruent face on the back side. So I can name these faces triangle ABC, triangle DFE. Then we can name the rectangles. Let me get this out of the way and use a different color and we'll get these rectangles rolling. All right, so rectangles CFEB, CFEB. So there's a rectangle. Rectangle CFDA. Rectangle ABED. All right, so there are all my rectangles. Now you can go back through and do the sides. AB, so I have line segment AB. I have segment BE. I have ED. I have DA. And now we can do the triangle. So that was the base. Get the triangle rolling. I have AC and I have CB. Then across the top I have CF. Across the side I have BE. Across the back side I have AD. I've already gotten that one. Actually, I already got BE, so I don't need that one again. Back side of the triangle I have DF. I haven't written that one down yet. And I have FE. Haven't written that one down yet. And I have DE, which I have already written down. So those are all of my segments. And then you can pick out the vertices C, F, E, B, D, A. Woo! All right, now for surface area. Surface area means you're going to cover up all of those faces. So surface area of this box, I'm going to move this around just a little bit here. That just kind of got all over the place, didn't it? Let's make that smaller and get it out of the way. Just screw and grew. All right, so let's do this first one. I have a rectangular prism. With a rectangular prism, think about those faces. The top and bottom are the same. The front and the back are the same, and the left and the right sides are the same. So I have 2 of the front and the back, right? I have 2 of those. I have 2 left, right, and I have 2 top, bottom. All right, so if I know the area of the front, I can multiply that by 2. So I have 2 and then 10 times 4 to find the area of the front. Plus 2, and let's get the side. That's a 4 by 4. And then I have 2 top, which is a 10 by 4, and bottom. All right, so I have 2 of each of those. That will cover that surface. 2 times 40 plus 2 times 16 plus 2 times 40 is 80 plus 36 plus 80. 80 plus 80 is 160. 160 and 36 is 196. And that is in inches squared. All right, good job. So 196 inches squared to cover that rectangular prism. All right, let's look at this cylinder. Surface area of a cylinder, if you think about unfolding that cylinder, you guys probably did this in middle school. If you cut along this and lay it open like a label, you have a rectangle. As I unfold that, or think about putting the label, wrapping the label back around it, this part right here matches the top. It would circle around that. We know the circumference of a circle is 2 pi times the radius. That wraps it around. And then we have the height. of that square, of that rectangle. So I end up with, on this one specifically, 2 pi times 4, and then the height is 9 of that label. Then I also have the surface area of the top and the bottom, which are identical circles, and the radius is 4 on both of those. They are the same size. So here is my formula, 2 pi RH plus 2 pi r squared, because I have a top and a bottom. This is the circles on the top and the bottom. This is the rectangle for the label. That's the surface area of a cylinder. You don't really need to memorize that if you can just think about that picture. All right, now it's just plug and chug. 2 pi times 4 times 9, so radius, height, plus 2 pi times 4 squared for the radius. All right, we can plug and chug that. 2 times 4 is 8, times 9 is 72 pi, plus 16 times 2 is 32 pi, so 104 pi, and then you can put that on your calculator to get an approximation if you would like to, and we can go ahead and round that to the nearest tenth. Let's see if Maggie will hand me a calculator. Can you hand that to me, Maggie? My lovely assistant Maggie, hand me my phone. Yes, she can do it. Good job, Mags. 2 claps for you. Maggie got 2 claps. And she's giggling. All right, so we'll put this in the calculator. 104 times 3.14, and you can do 3.1415 if you want to. So about 326.6, let's go centimeters squared for the area there. All right, nice job. Okay, let's finish up with these last two. We're going to talk about volume. All right. Volume of the cylinder. All right, so if you think about stacking some circles in here, stack them up, stack them up, stack them up. A circle is pi times the radius squared, and then we're going to multiply it by the height to stack those up. That's the formula for volume of a cylinder. So pi times the radius squared multiplied by the height. Square the 5 first, so 25, and then 25 times 2 times pi, so 50 times pi, and we can just leave it as 50 pi, or about 157 centimeters. Now we're cubic meters because we're talking about volume. All right, going over here to this little cube. Volume of a cube. By the way, volume of any prism, area of the base multiplied by the height. Remember, we're all about that base. All right, area of the base multiplied by the height. My base on this one is a circle, so we did pi r squared. My base on this one is a square, so I will do length times width and then multiply it by the height. So length, width, height. Remember, area of the base multiplied by the height, so check out your base. All right, 3 times 3 times 3 is 27 inches cubed. All right, that's it, guys. Talk to you later. This is Coach Lowe, and I'm out.